When you type a word to an AI, it never actually sees the word. Not the letters, and not really even the word itself. Before your text ever reaches the model, it gets quietly chopped into pieces called tokens, and those pieces are the only thing the AI ever works with. It is reading a completely different version of your message than the one you typed. And this one invisible step, the one that happens before the AI even starts to think, quietly explains a whole pile of its strangest habits. So let me show you what a token actually is, because once you see it, these machines get a lot less mysterious. Here is the natural assumption almost everyone makes. You typed letters, so the AI must read letters the way you and I learned to in school, sounding out S-T-R, a W-B-E-R-R-Y, one character at a time. It does not do that. And it also does not quite read whole words, which is usually the next guess people land on. What actually happens is stranger and honestly more practical. Your text gets broken into tokens, and a token is just a common chunk of text. Sometimes it is a whole word. Sometimes it is a piece of a word. Sometimes it is a single character or even just a space. The model then deals only in these chunks, start to finish. The actual letters sitting inside those chunks are not something it looks at directly. They are sealed inside the piece, like writing on the inside of a sealed box. So how does the chopping actually happen? Long before the model was ever used by anyone, its makers ran an enormous amount of text through a process that hunted for the most common chunks in the language. The really frequent words, the, and, is, you, of, each got their own single token because they turn up absolutely everywhere. Common word parts like ing, ed, pre, tion became their own tokens too. Whole words that appear constantly earned their own token, while rarer words got left to be built out of those smaller pieces. So a common word like apple is probably one clean token. A less common word like tokenization might get split into tokenization or even into more pieces than that. And something genuinely unusual, a long medical term, a random password, a word you just invented, gets shattered into a fistful of tiny fragments. The end result is a fixed vocabulary, usually somewhere around 50 to 100,000 tokens, and every single thing you type gets expressed as a sequence drawn from that set. Your sentence goes in as letters and comes out, before the model even glances at it, as a string of these puzzle pieces. To make that concrete, take a tiny sentence. The cat sat. To you, that is 3 words and 10 letters. To the model, it might be 4 tokens, one for a space and cat together, one for a space and sat together, and one for the period. Each of those is really just an ID number, a slot in its huge vocabulary. It does not see C, a T. It sees token number 40,000 and something, which it has learned tends to behave like a small furry animal inside sentences. All the meaning lives in how that token relates to the others around it, not in any letters, because the letters were thrown away the instant the chunk was formed. And this is where all those strange behaviors come from. Remember, the model only ever sees the chunks, never the letters locked inside them. So ask it how many R's are in strawberry, and it genuinely struggles because to it, strawberry might just be the 2 chunks straw and berry, with the actual letters sealed away. It is being asked to count something it cannot really look at. That same blind spot explains why it sometimes fumbles spelling a word backwards, or counting the characters in a sentence, or hearing that 2 words rhyme. None of those are the model being dumb. They are all the same thing. The letters are behind frosted glass. But tokens explain more than just the goofy failures. They also quietly run the money and the speed. AI companies charge by the token. And the model can only hold so many tokens at once, which is that context window we have talked about. So a page of plain English is cheap, because it packs down into relatively few tokens. But text in certain other languages, or text crammed with rare words and odd symbols, gets chopped into far more tokens for the very same amount of meaning, which makes it slower and more expensive to handle. The token is the hidden unit of cost, speed, and memory, all at the same time. This token tax shows up in surprising places. A single emoji can quietly eat several tokens. Languages that do not use the Latin alphabet, or that pack lots of meaning into long words, often need 2 or 3 times as many tokens to say the exact same thing as English does, which is part of why these tools can feel slower, pricier, or even a little dumber in some languages than in others. It is not that the model dislikes those languages. It is that the chopping was mostly tuned on English-heavy text, so everything else gets cut into more pieces, smaller and clumsier ones. The tokenizer has a home language, and it quietly favors it. So what do you actually do with this? A few things, and they are genuinely useful. First, whenever you need something at the letter level, counting characters, exact spelling, a precise find and replace, just remember the model is half blind to the letters underneath. So either spell the word out for it one letter at a time, which turns each letter into its own little token it can finally see, or simply check its answer yourself. Second, if you're paying for an API or bumping into length limits, know that trimming your text or just writing more plainly literally costs you fewer tokens and buys you more room to work. Shorter and cleaner is not only nicer to read, it is cheaper for the machine. And third, this is the big one, tokens are your clearest window yet into a deep truth about these models. They do not experience language the way you do. You see meaning, and you see letters. They see a stream of statistical chunks and nothing else. Almost everything that feels uncanny about them, the brilliance and the silly mistakes sitting right next to each other, traces straight back to that gap between how you read and how they read. It is worth sitting with that for a second, because it reframes the whole thing. We naturally imagine there is a little reader inside, someone who learned language the way a person does, letters into words into meaning. There is not. There is a system that was handed a giant pile of these chunks and got extraordinarily good at guessing which chunk tends to follow which. It never learned to read in our sense at all. It learned the statistics of the pieces. That is why it can sound so deeply human and then trip over something a 6-year-old would nail. It was never doing the thing we thought it was doing in the first place. So the next time an AI does something weirdly brilliant and then stumbles over something a child would get right, picture that invisible first step. Your words, quietly shattered into chunks before the machine has even begun. It is not reading your message. It is reading a tokenized shadow of it and then predicting the next shadow, one chunk at a time. Once you can actually see the tokens, half the mystery of these tools just quietly evaporates. And that is exactly what we do here, one clear idea at a time.